Okay, so this is some extra practice converting from polar into rectangular. So there are two things you're going to do. First, you're going to convert, and then second, you're going to do a quick sketch of what this polar equation looks like. A reminder, as we talked about in the notes video, you're going to use your rectangular equation for the sketch. We are not expecting yet that you are, or that you know how to sketch in polar form. However, if you're starting to notice some patterns, it could potentially help with an upcoming lesson. Okay. So first up, we have r equals 8 sine theta. A reminder that this is supposed to be kind of like whiteboards in class, so you really should be pausing the video, trying it on your own, and restarting when you're either stuck or have an answer. If you have not watched the notes video yet, you really should watch the notes video first. This is designed to support what was already explained in the notes. Okay? Go ahead and pause the video, give r equals 8 sine theta a shot, and restart it when you're ready. Okay, so this particular one's going to go with the second set of steps that we wrote down. First up, we want to rewrite and replace our trig. Again, we're looking for either a sine theta or a cosine theta, and if we don't see that, if we see some other trig, we're looking to manipulate that trig to get sine or cosine. Or potentially tangent. I also know what I can substitute in for tangent, but usually cosine or sine. And in this case, I have a sine. So that's going to make that first step pretty easy. We're going to go ahead and substitute in for our sine. So we have r equals 8. And then sine theta, if you look at the top of your 10.2 notes, you'll see what sine theta equals. Sine theta is y over r. Okay, step 2, we're going to go ahead and isolate or manipulate to isolate r. Ultimately speaking, our goal usually is to try to get an r squared. Again, that's not going to happen every time, but that's what we're keeping in mind as we go. But in this case, I want to start by isolating my r because I have one on the left and one on the right, so I need to bring them together. Okay, and so in this case, I can multiply this r over to the other side. R times r is r squared. On the other side, we have 8y. And lo and behold, I've got an r squared, which means I can substitute in. I know what r squared is. R squared is the same thing as x squared plus y squared. Which brings me back to my last step. I am now going to manipulate this, solving for a form that I can graph. This particular one is going to be a circle. We have two squares. So we do need to do a complete square on that y element. So let's go ahead and subtract the 8y, over to the other side. Just going to leave this 0 on this side. And the question is, what does that number need to be? Okay, well, half of negative 8 is negative 4 squared is 16. And we've got our circle form. This is x squared plus y squared minus 8y plus 16 simplifies to y minus 4 quantity squared. And at the back we have equals 16, which I'm going to rewrite as root 16 or 4 squared, because that way I can actually see my circle form. Okay. And then quick little sketch of our graph here. This again is a circle. What's my HK? Okay, my HK is 0, 4. 0, 4. And what's my radius? Radius is 4, so we're going 4 in every direction. We've got our circle. Okay. Go ahead and pause the video, give this next one a shot, restart it when you're ready. Okay, this one actually goes with number 7 in your notes. It is the first set of steps we wrote down. The others will all be the second step, or second set. First step, we know it's that first set of steps because there is no r or r squared. When you see yourself lacking an r and r squared, you're looking to get that tangent idea. So first step, we're going to take the tangent of both sides. Okay? And so what is the tangent of negative 3 pi over 4? Okay, well, negative 3 pi over 4 is in the third quadrant, so tangent is positive. Remember, negative means we go clockwise around the unit circle, so we're in the third quadrant. And the tangent of any pi over 4 angle is 1. And so this would be positive, because it's the third quadrant, 1. Okay, we're on step 2, which is we're going to replace that trig. Tangent of theta is the same thing as y over x, which brings me to my last step, which is to solve for y so I can get this into a form I know how to graph, which means we are going to multiply that x to the other side. We have y equals 1x, which is a graph we should all be pretty comfortable graphing. That is a line. What is its y-intercept? Y equals mx plus b. Its y-intercept is 0. And what is its slope? It's m. Slope is 1. Or you could do a little xy t-chart if you wanted. If you weren't comfortable pulling out m and b, do a little xy t-chart, give yourself a couple of points to plot, and you've got your graph. Okay, go ahead and pause the video, give this next one a shot, restart it when you're ready. Okay, first step, we want to rewrite and replace the trig. Well, there are no trigs. Step 1 done. Step 2, manipulate to isolate r with the ultimate goal of getting r squared. Well, I've already got r by itself. So step 2 almost done. Again, our ultimate goal is to get r squared. Well, this is not r squared. So how could I get this to be r squared? Well, I'm going to square both sides. I have r squared on one side, and negative 8 squared is 64. With that, I can now plug in. R squared is the same thing as x squared plus y squared. And we've now got a circle formula. X squared plus y squared equals r squared. And you can do a quick little sketch. Where's your HK? Our HK in this one is at 0, 0. And your radius? Your radius is 8. Okay. And you've got your sketch. Okay, go ahead and pause the video, give this one a shot, restart it when you're ready. Okay, step 1, rewrite and replace the trig. Well, secant is not a trig that I know how to replace within our polar ideas, so we do need to rewrite secant. How could I rewrite secant? Okay, well, secant is the same thing as 1 over cosine, and so I could rewrite this as 3 over cosine, which will now allow me to replace my trig. Cosine theta, we know what that is. Cosine theta is the same thing as x over r. Okay, step 2, isolating our r with the ultimate goal of eventually getting r squared. Let's go ahead and multiply both sides by that denominator, x over r, which leaves me with x equals 3. What do you know? I can graph that. I don't need to go any further than that. We know what x equals 3 looks like. What does x equals 3 look like? X equals 3 is a vertical line through x equals 3. It satisfies the idea of no matter what y equals, whether y equals 1, 2, 3, 4, negative 5, negative 10, x will always be 3 for all of those. 3, 5, 3, negative 10, all of those points would lie on that vertical line. Okay, last one. Go ahead and pause the video, give this one a shot, and restart it when you are ready. Okay, As I mentioned in the notes video, there are a couple of ways of doing this one. They are all right. I'm going to do this one the same way that I did it in the notes video. However, if you would like it to see it the slightly different way, the one that I mentioned in the notes video, I did end up doing it the other way on the homework help video. And so if you'd like to jump over to the homework help video, do number, I think I did 19 if I remember correctly, or it was somewhere around number 19. You'll see it again on the homework help video. You could do number 19 and kind of see it the other way. Honestly, it's not that different. It's just a slightly different way of thinking about it. Okay? But like I said, I'm going to do it like we did in the notes, which is I always like multiplying my denominator over to the other side when it comes to ones like this. And then I'm going to distribute the Rn as I do that. So R times 1 is going to be R times cosine theta is R cosine theta. On the other side, these have canceled, leaving me with just 4. And now I can go ahead and substitute in. I know what cosine theta is. Cosine theta is the same thing as x over r, which leaves me with r plus x equals 4. Okay? Second step, isolate r with the ultimate goal of getting r squared. So we're going to go ahead and subtract that x over to the other side. Okay? And then how can I get this to be r squared? Okay, well, I'm going to square both sides. And so I have r squared equals, over here, if I FOILed this, first outside, inside, last, for these two terms, negative x plus 4 times negative x plus 4, I'd have x squared minus 8x plus 16. Which I can now substitute in for r squared. R squared is the same thing as x squared plus y squared equals x squared minus 8x plus 16. Okay? Last step, solve for a form you can graph. This one is going to end up being a parabola because when I subtract this x squared over here, the x squareds are going to cancel. So since I have only one squared element, it's a parabola. I am going to flip this equation as I rewrite this. I'm going to put this negative 8x plus 16 in front and the y squared at back. So just spinning it. It's not quite in the parabola form though because we do have negative 8x and we want it to just be x. So we have two more steps. First step, we're going to factor that negative 8 out. Which brings us to last but not least, dividing that 8 over to the other side. Okay, and we can now graph that. That is a parabola. Now this is an x equals parabola, so it's going to go sideways. Right, so what's your HK? Our HK is 2, 0. This is a negative a, so I know I'm a leftward faced parabola. If this was a y equals parabola, it would be a downward facing parabola, but we're going to be facing left. And then, again, a reminder, you can think of it whichever way you preferred to think of it back when we were first learning this, which is you can think of the a as being your stretch. Just remember that it only affects one extra point on either side of your vertex if you think of your stretch. Or you could create a little XYT chart for yourself, whichever one you prefer. Okay, I myself, when I did this one, did an XYT chart, and I plugged in for y, negative 4, and 4. Only because I looked at negative 4 and 4, saw that I'd get 16 when I squared it, and 16 and 1/8 simplify pretty nicely. Right? 16 and negative 1/8 would make negative 2, and when I add the 2 over, I get x equals 0 for both the negative 4 and the 4. And so they're pretty nice points to graph. Again, nothing I would say super fancy about those. Even negative 2 and 2 would be pretty nice to plug in. Negative 2 and 2 plugged in would give you a decimal, but a 0.5 decimal. You might not mind using that. As long as you can get your sketch, you're good to go. Okay? Okay, that's it for extra practice for 10.2. Again, if you need anything else related to 10.2, let us know. We'll get that created in your way ASAP. Yeah, we're here to support you.